Okay, we're back. We're going to go over very briefly the homework on page 179 on derivatives of inverse trig functions. Let's go. Number 11 says find the derivative of the function f of x equals arcsine 2x. And specifically to do it at the point root 2 over 4 comma pi over 4. Okay, first of all, an aside, suppose you find yourself in a situation where you don't know how to find the derivative of arcsine. And this is a situation you will find yourselves in often. So the bad thing to do is to just look it up because then you're not really learning it. The better thing to do is to just rederive it on the spot. And honestly, this is really not that hard once you do it a couple of times. I know we've done this before in previous videos, but just to prove a point, I will just, like you might, pause and just do a quick rederivation of this if you totally forget. And how do you do it? The way we did it was to call this function y, or this, yeah. And then rephrase this in a way which is more clear. So this means that the sine of y is x. Now we differentiate both sides with respect to x. The derivative of sine y is cosine y back inside dy dx. And the derivative of x is 1 if you're differentiating with respect to x. And therefore, in a couple of seconds really, I determined that the derivative of y with respect to x is in fact just secant y. That's not really the answer I want because y was just my temporary name I made up for arcsine. So the real answer to this problem is secant arcsine. And that is, though not wrong, sort of unhelpful because it's sort of unsimplified. And so we want to know, well, what is the secant of arcsine? So the way to do this is to draw a picture of the arc of the angle whose sine is x, which is what arcsine is. And okay, it does matter whether x is positive or negative, but in this case, who cares? So we'll do it the sort of cheap way, where I'm assuming that x is positive. Therefore, my angle arcsine x will be a first quadrant angle. And well, what is an angle whose sine is x? It's an angle such that the ratio between the opposite and the adjacent is 1. And so there you go, the sine of y is x, and so this is a picture of arcsine. Then that makes that 1 minus root 1 minus x squared, and so the secant of that, I can read it right off the picture, is the ratio between the hypotenuse and the adjacent, so this is 1 over root 1 minus x squared. Okay, so I don't know, that took what, 2 minutes, 1 minute, less? And that's what you do in the future when you need to know the derivative of arcsine. Well, supposing I have that memorized already, then this is just a simple application of this. What is the derivative of arcsine 2x? Well, the derivative of arcsine of something is 1 over the square root of 1 minus that something squared back inside for the derivative of that something, so times 2. And maybe you want to write this as then therefore just 2 over root 1 minus 4x squared. So that's that whole problem. And we want to know, I guess, the equation of the tangent line to the graph at this point. Okay, well, then that's what the derivative is for, to tell me the slope of the tangent line to the curve at that point. So now I just plug in root 2 over 4 into this formula, and I get, let's see, it's actually better if too late. If I plug in root 2 over 4, then I get, when I square that, I get 2 over 16, so that's times, so it's an eighth, times 4 is a half, so it's 1 minus a half, so that's a half, and so that's 2 over root a half, but okay, that's really just 2 root 2. I probably did that right. Sure. I can double check it, but I don't feel like it. 1 over root 2, 1/2. Yeah, I think that's right. 1/2 root 1/2, yeah. Okay, well, therefore, then the equation of the tangent line would be y minus pi over 4 equals the slope to root 2 times x minus root 2 over 4. And that would be it. You just leave it like that. Okay, one down, many to go. Let's just push on. 14 is a very similar problem. It's almost the same problem. It's what is the arc secant of x? And we want to know the slope of the tangent line at the point root 2 comma pi over 4. Okay, I'm not going to spend time redoing the entire derivative of arc secant because I made a whole video about that. So I will just know that the formula is, let's see, do I have these formulas memorized? Yeah, I guess I do. It's 1 over absolute value of x root x squared minus 1. And so if I plug root 2 into this, then I get 1 over root 2 times, I guess that's it, right? Because when you plug root 2 in here, you get 2 minus 1 is 1 squared and 1 is 1. So boom. Therefore the equation of the line would be y minus pi over 4 equals the slope, which is 1 over root 2 times x minus root 2. Okay, moving right along, number 17 is just an implicit differentiation problem, just for fun, I guess. So we take the curve x arctan x equals e to the y, and we want to do it at the point 1 comma ln pi over 4. So I'll take their word for that. That 1 comma ln pi over 4 is in fact a point on that curve. If you plug in 1, yeah, well if you just plug in 1 for x and ln pi over 4 for y, then it's satisfied. Okay, how do you do this? Well, I need to differentiate both sides with respect to x. So I need to take the derivative of x arctan x on the left and the derivative with respect to x of e to the y on the right. Here I have to use the product rule. So the derivative of the first times the second, so arctan x, plus the first, x times the derivative of the second. What is the derivative of arctan? Well, okay, I just know that that's 1 over 1 plus x squared. And on the right-hand side, I want to take the derivative of e to the y with respect to x, though. So the derivative of e to the something is e to the something back inside for the derivative of the something. And so, well, what is dy dx then? It's just like that over e to the y, so this is a little boring. So arc tan x plus x over 1 plus x squared all over e to the y. Okay, and now, sitting on the ground here, find it at the particular point. So the final thing I need to do is to evaluate this at the point 1 comma ln pi over 4. And that's what this whole thing is over here. It's a formula which will tell you the slope of the tangent lines of the curve for any point x comma y. So we do it, and we get arctan of 1 is pi over 4. Here we get 1/2, I guess. And down here, e to the ln pi over 4 is just pi over 4. Okay, so I don't know if that can be simplified further. Of course it can, but I'll just leave it like that. Okay, these are just little practice problems. Essentially, all these problems are really doing are getting you to practice using the derivatives of the inverse trig functions so that you can know those formulas a little bit better. So these are not really like deep or really fun problems, I guess. Okay. Keep going. 21. Just do the derivative, man. So G is 3 arc cosine x over 2. If I did that right? So just like find the derivative. Okay, I just know the formula for the derivative of arc cosine. So just like fact, the derivative of arc cosine is the opposite of the derivative of arc sine. So it's -1 over root 1 minus x squared. And by the way, that just makes complete sense that that would be so. because arc sine and arc cosine are really the exact same shape, right? If you think about the arc sine function, at -1 it's negative pi over 2, and at 1 it's pi over 2, and it has the reverse curvature of, sorry, I zoned out for a second, so it's going to be like that. So that's arc sine. So it has a certain slope. It's going to be positive and like almost infinity basically, and then getting smaller, and then being the smallest it will ever be is 1 at the origin, and then back up to positive infinity. That's arc sine x. What does arc cosine look like? Well, arc cosine is going to look like this. I just kind of have this memorized, but it is definitely right. That when you take the arc cosine of 1, you get 0. When you take the arc cosine of -1, you get pi. And so arc cosine has to slope like negative infinity, and then it gets smaller. It's not really flat there. It's a little bit wrong. It's kind of like 1 is the slope at 0 comma pi over 2. Anyway, the point is that this is the same shape, right? This is the graph of arc cosine. So if that helps you remember that, in fact, their slopes are opposites of each other. And so there's really only 3 formulas to memorize, not 6, in my opinion. Keeping this fact about arc cosine in mind, well, now we just do it using the chain rule. So this is 3 times. What's the derivative of arc cosine of something? Answer is it's -1 over the square root of 1 minus x over 2 squared. Back inside for the derivative of the something, and so we have times an extra half in there. Okay, let's just like do this really fast. 25. 25 is just arc sine 3x over x, so arc sine 3x over x. And okay, I guess I have to use the quotient rule, or at least I should use the quotient rule. So let's go. So this is sort of the top times the bottom. So what is the derivative of arc sine 3x? It's 1 over root 1 minus 3x quantity squared back inside 3. So the derivative of the first times the second minus the first times the derivative of the second. This problem is kind of annoying too. All over the bottom squared. I don't feel like simplifying that at all. So I'll just leave it, but I'm pretty much sure I did it right. To the top times the bottom minus the top times the derivative. Yeah, looks good. Okay, 29 is just like another thing. It is just like another thing. 29, what is the derivative of arc cotan 6x? Arc cotan 6x. Well, I happen to know, for similar reasons, that the derivative of arc cotan is just the opposite of the derivative of arc tan. And so, I guess I'll write it right here. What is the derivative of arc cotan? This like never comes up. So this is not that important really, but the derivative of arc cotan is just -1 over 1 plus x squared. So keeping that in mind, I have to now use the chain rule here. It says that the derivative of arc cotan of something is -1 over 1 plus something squared back inside for the derivative of the something. So there you go. Okay, 3 to go. 33 is just more, man. Oh, something kind of cute happens here though, I think. We take the curve, y equals x arc cosine x minus root 1 minus x squared. Yeah. And I think if you do this right, something sort of interesting happens. So what is the derivative of this? Well, I have to use a product rule, so it's derivative of the first times the second. Plus the first x times the derivative of the second. And what is the derivative of arc cosine? It's, as we discussed, negative 1 over root 1 minus x squared. Okay. Derivative of the first times the second plus the first times the derivative of the second. And now I'm going to subtract whatever the derivative of root 1 minus x squared is. Well, that's 1 minus x squared to the 1/2. So it's going to be 1/2 1 minus x squared to the negative 1/2 back inside for the derivative of 1 minus x squared, which is negative 2x. Okay, that is kind of barely legible there, but I think I did that right. The derivative of 1 minus x squared to the 1/2 is 1/2 1 minus x squared to the negative 1/2 back inside negative 2x. And so what do we get here? We get, rewritten a little bit, we get arc cosine x minus x over root 1 minus x squared. And then here we get, okay, well the negative 2x and the negative 2x and the negative 1/2 cancel, and so we get plus x over, that is root 1 minus x squared. And so actually this is arc cosine. Whatever. That original function is something whose derivative is arc cosine. I don't know. Okay, 2 more and then we'll call it a day. This is just really all just practice with the formulas. What are we doing? Find the equation of tangent on the graph. Okay, so we get y equals arc tan x over 2. And now we are going to find the equation of the tangent line at the point 2 comma pi over 4 at 2 comma pi over 4. So we do it. What is dy dx? Well, I already know the derivative of arctan. It's 1 over 1 plus thing squared. So the derivative of arctan of something is 1 over 1 plus something squared back inside for the derivative of the something. So times 1/2. So that's my formula, and I'll just leave it like that. And so I want to know the slope at the point 2 comma pi over 4. So I just plug in 2 for x. And if I do that, what do I get? I guess I get 1/2 over 2. So it's 1/4. Does that look right on the picture? Sure. Let's see, just double check that. 2 over 2, 1 squared is 1, 2 in the bottom, 1/2 in the top. So that's 1/4. And therefore the equation of the tangent line would be y minus pi over 4 equals 1/4 x minus 2. Okay, last problem, 51, says, find equations of all tangent lines to the graph of arc cosine that have slope negative 2. Okay, so I have my function f of x equals arc cosine x. Here's a picture of it, and I want to know all the places where the slope has negative 2. Okay, well, just by ballparking it, like, I don't know, it seems like there's going to be one here, and there's going to be like another one over here. It seems like those 2 red lines have slope negative 2. And so I just need to find those places. And I guess that's the whole problem, right? Find equation. They want me to find the equations of the lines. Okay, well, I will take the derivative of arc cosine. We know it is negative 1 over root 1 minus x squared. And I want to know when is this derivative equal to negative 2. So I just set it equal to negative 2, and now I just have an equation to solve, and that equation is negatives cancel, so that's like 1 equals 2 root 1 minus x squared. And now if I square both sides here, then that gives me 1 equals 4 1 minus x squared, well, sure. Okay, so 1 is 4 minus 4x squared. So 4x squared is 3. So x squared is 3/4, kind of a very slow version. And so what is x? X is root 3 over 2. Okay, and that seems actually very reasonable according to, I guess plus or minus. So that's exactly what my picture tells me, or something pretty similar. If x is plus or minus root 3 over 2, then the slopes of the tangent lines through the graph of arc cosine will have slope negative 2. That seems about right. Okay, and I now know that my 2 points are root 3 over 2. What is the arc cosine of root 3 over 2? It's the angle whose cosine is root 3 over 2. Well, that's pi over 6. So that's 1 point. And what about when you plug negative root 3 over 2 into arc cosine? Well, that's going to give you the angle whose cosine is negative root 3 over 2. That will be 5 pi over 6. And those are my 2 points. And this graph has a slope negative 2 at each of those 2 points. And so the 2 equations are y minus pi over 6 equals negative 2 x minus root 3 over 2. And y minus 5 pi over 6 equals negative 2 x plus root 3 over 2. That is probably right. Okay, and there we go. That was just a little homework, possibly a few too many problems, using the formulas for the derivatives of the inverse trig functions. So hopefully that was helpful to some people. Okay, bye.